All right, let's start talking about the warm-up. What kind of triangle is pictured there to the right? It is a right triangle. Thank you. Over there, bottom two. All right, so a right triangle tells me about the angles. Every triangle has two words that make up the type, one that's describing the angles and one that's describing the sides. So we talked about a right triangle. For the angle part, it's either right, obtuse, or acute. And then I need a word that describes the side lengths relationships. So I'm looking for equilateral, isosceles, or scalene. Which one would this be? Isosceles. Do we have two sides that are the same size in the picture? Scalene. There we go. So this is a right scalene triangle. Oh, I forgot an E on there. There we go. Right scalene triangle. Isosceles triangles have two congruent sides. Equilateral triangles have three congruent sides, but isosceles triangles have no congruent sides. All three are different lengths. All right, what is the hypotenuse of triangle ABC? BC. Does need to have that segment notation over the top. If you just write BC without that segment notation over it, you're telling me that the hypotenuse is a number, that it's a length, like 5 inches. The hypotenuse is not a number. The hypotenuse is that whole segment, so that's why we put the dash over the top. What is the side that is opposite angle C? BA or AB. When you're writing segments, the order of the letters does not matter. What is the side that is adjacent to angle C but is not the hypotenuse? AC or CA. Same question, but about angle B. What is the side that is adjacent to angle B but is not the hypotenuse? AB or BA. Very nice work. All right, go ahead and pull out your notes. We're going to be on page 6. Do you have these? Okay. Back side of the third piece of paper, page 6. Today we're going to learn how to use sine, cosine, and tangent to find missing angles. And then we're going to put all of the ideas together from the first part of this module all the way through what we're learning today. Before I can teach you how to find missing angles, though, there's a little bit of notation that we need to talk about. And that is this weird-looking symbol right here. It looks like a capital letter O with a line drawn through the middle of it. That is a Greek letter. It's called theta, just like how we have A, B, C, D. They had letters with different names and different looking symbols. So this Greek letter theta is what we use to represent unknown angles. Nope, don't write this part on the line. I'll write on the line what you need to write on the line. Right now, we're just defining what that weird-looking symbol is. Theta is used for unknown angles. So one of the reasons they do this is so that we don't get confused about whether we're looking for an angle or whether we're looking for a side. We'll use things like X, Y, and Z for missing sides that we're trying to find. And we'll use Greek letters for missing angles. Usually it's going to be theta. Every now and then there's another Greek letter. So if you see any other weird-looking symbols, we'll talk about what that means. But it's probably a Greek letter, and it would be used to find a missing angle. All right. To actually find those missing angles, we must use inverse trig. So you guys actually already know some inverse operations. An inverse operation is one that undoes another operation. So for example, what undoes addition? Subtraction. So subtraction is the inverse of addition because it undoes it. What undoes division? Multiplication. So multiplication is the inverse of division. So we are going to use inverse sine, inverse cosine, and inverse tangent. These little -1 symbols are what mean inverse. So if it's just TAN without the little -1, that's regular tangent. If it's TAN with the little -1, then it is inverse tangent. These are buttons on our calculator, just like sine, cosine, and tangent are. To get to these buttons, though, we have to use the green second button on the calculator. Yeah, the like green oval-shaped one. You have something else. I'll help you find it on yours. It's probably shift on your calculator then. I'll help you locate it on there before we actually use it. All right. So we're going to use inverse sine, inverse cosine, inverse tangent whenever we are looking for angles. If I'm looking for a side, I don't use the inverse, just when I'm looking for an angle. All right, so I'm going to demonstrate with example A on number 4 how we use these inverse functions. We're still going to follow our 3 steps that we did yesterday. We're going to circle the angle. We're going to label our sides. We're going to pick our function and write our ratio. So on part A, I'm going to circle the angle that we're looking for, this angle theta. This is where we are standing in the triangle. And then I'm going to label my sides up. We're going to label the hypotenuse first. Hypotenuse is this side right over here. Then we label our opposite side. How big is the opposite side here? 8. And then we label which side? Adjacent. What's the adjacent side here? 20. Remember, adjacent means touching or next to. Notice it is touching. It is next to my angle theta. All right. We've circled our angle. We've labeled our sides. Now we break out SOHCAHTOA, S-O-H, C-A-H, T-O-A. When I'm looking for an angle, I have to have numbers for the 2 sides that I'm going to be using.
So tan?
Tell me why you picked tan.
Because we don't have a
Yep, we don't have the hypotenuse. We don't have h, so I can't use sine because that uses the hypotenuse. Can't use cosine because that also uses the hypotenuse. So you're absolutely correct. We are going to use tan. I set it up exactly the same way that we set them up yesterday. So I have tangent. So T-A-N. And then parentheses, and inside the parentheses is where we put our angle. We don't have a number for our angle this time. We just have this symbol, theta. And then we set up our fraction with opposite over adjacent. How big is the opposite side? 8. And the adjacent? So 8 over 20. If this were a normal equation like x plus 5 equals 7, what would you tell me to do next on this problem?
Subtract.
Why subtract? I like it. You're right. We need to get x by itself. So we want to make that 5, that plus 5 cancel out. And what cancels out addition is subtraction. Well, here, I need to get the theta by itself. That's my unknown thing. The way we do that, the way I get tangent to the opposite side is by using inverse tangent. So if tangent moves to the other side of the equal sign, it becomes the inverse. But my 8 over 20 stays exactly the same. So anytime I have a trig function that goes to the other side of the equal sign, it turns into the inverse. Now I can pop this into my calculator. On my yellow calculators, first thing we need is inverse tangent. So you have to start by pushing the second key, and then you push tan. If you don't see tan with the little -1 show up on the screen, then clear everything out and do it again. Second and tan. It'll open up parentheses for you, and that's where we're going to put the 8/20. So then it would be 8. What should I use instead of the fraction bar? Division. And then 20. Close your parentheses and hit enter. What do you mean? No, it won't make a difference at all if you use the fraction key instead of the division key. Yes. You could use either one. I usually just go with division because it doesn't make a difference. It's the N/D button right here. Oh. What'd you guys get when you hit enter? 21.801. And we just found an angle, so we put the unit of degrees on this. What? Degrees. Anytime we find an angle, so anytime we're finding theta, we're going to put degrees on our answer. John, were you able to find it okay on yours? Okay. Let's try example B now. Same 3 steps from yesterday. Circle, label, set up. What are we circling? We're going to circle this guy right here, the theta. This is where we're standing. Then we label the hypotenuse. What's the hypotenuse here? 75. Then we label the opposite side. Where's the opposite side? We don't have it, but I'm still going to label it. Here's my opposite. And so this 21 up at the top is adjacent. All right, we circled, we labeled. Now we break out SOHCAHTOA. SOHCAHTOA. We're going to use which one? C. Tell me why. Yep, we don't have the opposite side. Can't use sine because it uses opposite. Can't use tangent because it uses opposite. You're absolutely correct. We're going to use cosine. So now we're going to set up the ratio. I start with COS and parentheses. What goes inside the parentheses? The angle theta. We don't know how big it is, so we use that variable theta for my angle. And then that equals adjacent over hypotenuse. How big is the adjacent side? 21 over the hypotenuse? 75. All right, now that I have it set up, I want to get the theta all by itself, which means I need to make that cosine go away. How do I get the cosine to the opposite side? Inverse it. So theta equals inverse cosine, cosine with a little -1, 21 over 75. Yep, give me 3 decimal places, and if you have to round up, that's totally okay. 73.74 or 739. I would accept either one of those. So 73.74 or 73.739. I'm going to give you guys about a minute to do part C on your own. I'm going to come around and check in with people that need help, and then we'll go through it together.
So do I have to type in?
You can't type that in. You can type this in.
So I just do. So it would be like for this. No, just that one. It would just be.
Nope. That doesn't have the little -1. That. Now push cos again. See how it has that little -1 just like that? Mm-hmm. And now inside the parentheses, you'll do 21 divided by 75. There you go.
Thank you.
You're welcome. because you're not using the inverse. You have to make it look like this on your calculator. You have to use this key right here. Nope, this key first. Now push that one. Oh, yep. See how it has the little -1 just like that? Now put in 21, and that shouldn't be 25. Should be 75. There you go. And then you type it in here. Not 25, it's 75. There you go. And because of this, that rounded that up, so that rounded that up.
Okay.
That's how we got that. Yes. What are we getting for theta? 36.869 or 36.87. Absolutely. Let's walk through it. Circle the angle. So we circle theta. Label our sides. 65 is my hypotenuse. 39 is my opposite side. Up at the top is my adjacent. We have to use which function? We have to use S. We have to use sine. We don't have the adjacent side, so I can't use cosine because that has an A. I can't use tangent because that has an A. So it has to be this first one, sine. So then we do sine of our angle, which is theta, equals opposite over hypotenuse. The opposite side is 39. The hypotenuse is 65. How do I get theta alone now? Inverse it. So theta by itself, when sine goes to the opposite side of the equal sign, it gains that inverse symbol, that little -1. 39 over 65. And then you pop that in your calculator. And you guys are absolutely correct. You get 36.869 or 0.87, depending on how you round it. I would accept either one as fully correct. All right. So now I want to put everything together that we have learned so far. So looking down at number 5, we are going to find all the missing pieces they're asking us for. Now there is one thing that I want to talk to you about because it shows up on your homework. You have directions on one of the homework problems that says you are supposed to solve the triangle. When it says to solve a triangle, what it means is to find all the missing sides and angles. So if it says to solve the triangle, we should know the sizes of all 3 angles and the sizes of all 3 sides. So we're actually going to do that for part A so that you guys have one example of what it means to solve a triangle. The others will only find the piece they're asking us for, but on this first one I want to solve the triangle. I notice in this triangle that there's a 90-degree angle and there's a 20-degree angle. Can I use that information to figure out how big this third angle would have to be? How do I do that? Absolutely correct. We're going to add those two together. You're welcome. So I'm going to take the 90-degree angle plus the 20-degree angle. When I add those together, I get how much? Try again. Add those two together. 110. And then we take that and we minus that from 180. 70. You were just a step ahead of me, Jesus. So there's my missing angle. So I'm going to add that to my picture. This is a 70-degree angle. So now I know all three angles. To finish solving it, I need to know all three sides. How many sides do I know right now? Just one. So we're going to have to find two of them. They're labeled as X and Y. We're going to circle the angle that they gave us. So I'm going to circle this 20-degree angle that they gave us. I could do it with the 70-degree angle, but it's always a good idea to use the one that they gave you in the problem. It means if you made a mistake finding the other one, you don't screw up the rest of your problems because you're going back to what was printed on the page. All right, so we circle our angle. We're going to label our sides now. Which side do we label first? Hypotenuse. What's the hypotenuse here? X. Then we label which side? Opposite. What's the opposite side of this triangle? 14. And so Y is which side? That's the adjacent side. Perfect. Now we bust out SOHCAHTOA. SOHCAHTOA. We're going to have to find them one at a time. Do you guys want to find X first or Y first? X. Sounds good. So X is which side of that triangle? Hypotenuse. So can I use tangent then? No, because it doesn't use the hypotenuse. So I have to decide whether I'm going to use sine or whether I'm going to use cosine. I can only find one thing at a time. So it's important that I only have one variable. I already have my variable picked out, X. If we go with cosine, will I have only numbers except for X? No, because the adjacent side is Y. That would be two variables. We have the opposite side here. So we're going to go with sine. So then I write down my function, sine of my angle. How big's the angle that we circled? 20 degrees. Is equal to opposite over hypotenuse. How big is that opposite side? 14, and then over X, because that's my hypotenuse. We want to solve for X. That means getting it all alone on one side. And right now, X is part of a fraction. How do I get it out of the fraction? Multiply. Should I multiply by the 14 or the X? Why? Because it's on the bottom. It's the denominator. If you do it to one side, you do it to the other side. So I multiply both sides by X. On the left, I have X times the sine of 20 degrees. And on the right, I have 14. Is X the only thing on the left-hand side now? No. How do I make it the only thing on the left-hand side? We got to divide by sine of 20 degrees. Yes. If you do it to one side, you got to do it to the other. So we divide both sides by the sine of 20, and then we pop it into our calculators. This is not an inverse, because I'm not looking for an angle. It's not a theta. So we do 14 divided by the sine of 20. And what do you get? 40.933 for X.
I got a question.
Mm-hmm.
When do you know to put or sine, cos, or tan in the one?
With the little negative one?
Yeah.
If you're looking for an angle, if the angle you circled is that theta and not a number, that's when you use the inverse ones. Because that's when we have to make it move to the other side without the angle going with it. Does that make sense? Awesome. All right, to find y, we got to bust out SOHCAHTOA again. SOHCAHTOA. I'm not interested in finding x anymore. I want to find y. So which function could I not use if I'm trying to find y? I can't use sine because I need the adjacent side. Here's the adjacent side, here's the adjacent side. Would I use cosine or tangent? Tangent. Why? We're looking for the adjacent, and which one do we have a number for? The opposite. So we're going to use tangent. I don't want to use any numbers that I just found, like that 40.933 I know is my hypotenuse, but I don't want to use that to find anything else because we already had to round that one, right? If you have had to round an answer, you don't want to use it to find another answer. All right, so tangent. What goes in my parentheses? 20 degrees. There's my angle. Is equal to opposite over adjacent. How big's the opposite side? 14 over the adjacent side, which is y. All right, what do I do next? Multiply both sides by y because that's in my denominator. Cancel my denominators out on the right. On the left, we have y times the tangent of 20 degrees equals 14. Then what? Divide. What are we dividing by? Tan of 20 degrees. And so when we do that, we get what for our adjacent side? 38.464 or 465, depending on how you round there. Do we know all three angles in the triangle now? Do we know all three sides in the triangle? Yes, we know all of those pieces. Stay with me, dear. Let's do part B. How many things are they asking me to find in part B? Just one. Just the angle. So let's circle the angle that they want us to find. This is where we're standing. We label which side first? Hypotenuse. How big's the hypotenuse here? 19. Then we label, how big's the opposite? 16. And so down on the bottom would be what? That'd be the adjacent side. So now we both bust out SOHCAHTOA. Which ones can we not use? T and C. They use the adjacent side, and we don't know the adjacent side. So we're going to have to use sine. So I'd have sine of what? What would go into my parentheses? We're going to put our theta in there. The angle goes in there. When I have numbers, I put the numbers in there. When I don't have numbers, I put whatever symbol I have circled.
On the other problem, we didn't have x. We still use this one, but we didn't know.
We didn't have x because it's the hypotenuse. And that's what we were looking for, but we did know the opposite side. So when I'm looking, that's actually a really good question. When I'm looking for an angle, that's the only thing that's allowed to be unknown. Everything else has to be numbers. When I'm looking for a side, I have to know the angle there. So I either have to put a number in here, or both of these have to be numbers. All right, opposite over hypotenuse. How big's my opposite side? 16 over my hypotenuse, 19. How do I get the theta by itself? Inverse. So theta is equal to the inverse sine of 16 over 19. And then we pop it in our calculator and we get what? 57.363. Should I put degrees on it or not? Yes, anytime our variable is the angle, anytime it's theta, we pop degrees on our answer. Very nice work so far. Couple more problems to go. Let's look at part C. How many things do they want us to find on part C? 2. What are those 2 things? X and theta. Which one do you guys want to find first? Sounds good. Let's find X first. Oh, on part C. We're supposed to find X and we're supposed to find theta. How many sides on this triangle do we know? 2. Didn't we learn something at the beginning of this module that lets me find the 3rd side on a triangle when I know the other 2?
We don't know those two, though.
We do know the other 2. This one is 26 and this one is 45. Hold on. When 2 sides of a right triangle are known, what do we use? What'd you say, Jesus?
PT.
Yes, we're going to use the Pythagorean theorem. So we are going to add it up, but before we can add it up, we got to square them. So Pythagorean theorem, a squared plus b squared equals c squared. What has to go in the spot for c? 45. Why do I have to put 45 in for c? Because it is the hypotenuse. You're right. So I'm going to go ahead and label it while I'm here. 45 has to go in for c because it's the hypotenuse. The other 2 sides, doesn't matter where I put them. So one of them needs to be 26, and the other one needs to be x. Then we take them and we square them. So x squared plus 26 squared equals 45 squared. What is 26 squared? 676. What is 45 squared? 2025. Next year.
I'm ready to graduate.
We're going to subtract 676 from both sides. All right, so I get x squared equals what? 1,349. Is that how big that side is?
No.
What do I need to do? Square root it. If you do it to one side, you got to do it to the other. So the squared and square root cancel on the left. On the right-hand side, I have x is equal to the square root of 1349. So we're supposed to simplify our radicals, right? I'm going to save us a little bit of time, though. 1349 is not prime, but it is the product of 2 rather large prime numbers, and that's why I'm not going to have you guys figure them out. This is 19 times 71, and both of these numbers are prime. So I'm not going to be able to find something times itself. So square root of 1349 is fully simplified, or I could put it in its decimal form. What would the decimal form be? 36.729 or 728, depending on how you round. All right. So there's our missing side. Now we need to find our angle theta. So now we're going to go through our steps to find that angle. Circle the angle up. This is where we're standing. We already have the hypotenuse labeled, so what should the next side be that I label? Opposite. Where's the opposite side? X. And so this 26 up here? Adjacent, A. All right, bust out SOHCAHTOA. SOHCAHTOA. C. Tell me why. We have the hypotenuse right here, and we have the adjacent side right here. So we are going to use cosine. So cosine of my angle, what's my angle? We don't have it, so we use the theta to represent that angle. Cosine of theta is equal to adjacent over hypotenuse. How big is that adjacent side? 26 over the hypotenuse, 45. How do I get theta by itself? Inverse it. So theta equals inverse cosine of 26 over 45. Pop that into your calculator and tell me what you get. 54 point, you said 705? 706, depending on how you round. That's absolutely correct. I want you guys to try part D. I'm going to give you about, let's take 3 minutes to do part D.
Yesterday, y'all win. We had practice. We had to practice there till 10. It was till 8, but by the time we got back to the school, it was 10. That's crazy. Because we one section of the regionals is at their school. We practiced today. How y'all win in the football? Yeah, but that's what happened. Practice. Can't do it. Then I was really got to sleep. I was sitting out in love. Oh, I gotta show you the show. What the mom say? He always talking something. Always got something to say. What you mean? Bro. Delete it. Oh. Bro. He was at the same time. Like, I got the picture. Of me? Relax. Remember it was over class. I think it might have been in this class. I love y'all. Me too. It's not about you, sweetie. But now it is. Anyway, that's dismissed. Yeah, look what she was saying. She. Here's to it's not for you, sweetie. Bye.
Yeah, mine.
Give me just a moment and then yes, because we're still going to do this one at the bottom. Hold on.
I would, but what he did was
Can you add those for me one more time? Oh wait, you minused it. You're just adding them. They're on the same side. The only time you minus is to get it to the other side. So just plus those together. Yeah. Mm-hmm. Are you sure that's the function you should use?
Yeah.
Well, which sides do you have numbers for? Opposite and adjacent. Which one uses opposite and adjacent? There you go. All right, let's walk our way through this one, and then we got one last problem to wrap us up. Do you guys want to find the angle, theta, or do you want to find y first? Sounds good. How do we find y? Pythagorean theorem. So a squared plus b squared equals c squared. What has to go in for c? The y right here. Because it's opposite my right angle, so that's my hypotenuse. So we put y in the place of c. That means the 70 and the 24 have to go in for A and B. Does it matter which is which? Nope. Okay, so 70 in for one of them, 24 in for the other. We have to square both of them. What is 70 squared? 4,900. What's 24 squared? 576 equals y squared. What do I get when I add the 4,900 and the 576 together? 5,476 equals y squared. Then what? Square root it. If you do it to one side, you do it to the other. Over on the right, my squared and square root cancel. What do you get when you divide 50? It's not divide, when you square root. You get 74 equals y. That one came out to a nice whole number. That's absolutely what we like. Then we need to find our angle theta. So this is where I'm standing. So now I need to label the rest of my sides. Where's the opposite side? 70. And my adjacent side is which one? 24. All right, bust out SOHCAHTOA. SOHCAHTOA. Which one should we use? Which sides do I have? I have adjacent and I have opposite. So we're going to use tangent. We do have the hypotenuse, so technically we could have used that. However, I never use that when I'm finding something else. I always use what's printed originally, because if I messed up finding y, it's going to mess up all the rest of this part then too. So I always go back to what's printed. All right, so tangent of, what's my angle? We don't know. So we put theta in there. So tangent of theta is equal to what over what? 70 on top, that's my opposite, over 24 on bottom. Now how do I get theta by itself? Inverse it. Theta equals the inverse of tangent, and then inside parentheses, 70 over 24. $71.075. What am I missing now? Degrees. Anytime we find an angle, we put degrees with it. All right. We're going to do the story problem at the bottom, and then we're going to call it a day. This one is very fast.
I thought the same way.
All right.
I'm thinking we done.
Nope, we got one more. Right down here. Mr. Tibbs needs to do some landscaping. He finds a great deal on oak trees at Trees R Us. He has 10-foot rope lengths to stake from the tops of the trees to the ground with an angle of elevation of 70 degrees. Approximately how tall are the trees he wants to plant? So we're going to draw a picture. First thing I'm going to draw is the tree. I'm not very good at trees, so it's going to be a Christmas tree. Where are the ropes? Top of the tree, down to the ground. So right here.
I don't know how to draw that.
What, a Christmas tree? You can draw any kind of tree you want to. I draw a Christmas tree because I am really bad at drawing trees. All right. So between the ground, the tree, and the rope, we have what kind of a triangle? We have a right triangle. Well, one of them is the height of the tree. That's like the trunk of the tree that goes right up the middle. And on the bottom is the ground. So here's the ground. This blue line is the rope. How big was the rope? No, how big is the rope? Not 10 degrees. It's 10 feet. That little mark means feet. Have you guys seen like that little thing before?
Yes, on your physical.
That is what means feet. If it has two little marks next to it, like this, that means inches. And I'll tell you, the only way I was ever able to remember the difference between those two, because I kept getting them confused. Do you guys remember in elementary school when you had to clap syllables to words? That's how I remember this. Inches, 2 claps, 2 little marks. Feet, 1 clap. That's the only way I was ever able to remember that. All right, we want to figure out how tall the tree is. So I'm going to call that X. Where should I put the 70 degrees? Where the 10 and the ground cross each other, right here. Because poor Mr. Tibbs is not going to be all the way up here. Like, he's got to attach it, but he's going to be up on a ladder, and then when he attaches it to the ground, he's going to be standing down there. So here's my 70 degrees. So this is where Mr. Tibbs is standing. What's the hypotenuse of this triangle? 10 feet. What's the opposite side? X. So where's the adjacent side? On the ground. All right, SOHCAHTOA. SOHCAHTOA. Which ones can we not use? T and... Which C and T? We don't have the adjacent side. We don't know how far along the ground he went. So I can't use tangent because I don't have adjacent. I can't use cosine, so we're going to have to use sine. Oh, you put the 70 in the wrong place? Yeah, that would affect it. All right, so sine of my angle. How big's our angle? 70 degrees. Equals what over what? X over 10. So what do I need to do to get the x all by itself? Multiply by 10 because it's on the bottom of my fraction. So 10s cancel out on the right-hand side. On the left, I have 10 times the sine of 70 degrees, and that I can pop right into my calculator. You said 396? What kind of units should we put with that since it's a story problem? Feet. You can do it with FT, or you could do it with that one little dash mark. Both of those mean feet. Now we are done.
Yep.
All right. You guys have a homework assignment that's due tomorrow. If you need another copy of it, it's the very bottom paper in that red organizer over here on the board. Tomorrow and Thursday, we're going to work on the same stuff we've been doing, but in story problems like what we just did. So that's what we're going to focus on for the next 2 days, but we're not learning any new skills. It's just practicing the same old skills with story problems.